Hello, welcome back to Blender Sushi Live Noding. In this episode, we're gonna recap what we have from last live noding and continue from there. So let's just grab this zip from my GitHub. Just right click and then copy the link locations. Providing you have Blender and Spherechalk add-on already installed, you can simply tap spacebar, tap zip, and load the URL. And it should kind of extract the zip and load it. Well, sometimes on my computer it crashes, but well, let's just reopen Blender and then quickly load the zip. That's because I'm using the Mac OS High Sierra. I don't know, it's a weird thing. So make sure you have Spherechalk add-on, and then once you have it, you just load the zip. I think just grab it like that. Okay, now we have the setup ready. Everything is good. And let's save this real quick. File, save as, save it on my desktop, vector V. So we already able to kind of scale the fracture. We want to position as well. So let's have a look. So this guy is a bake version, and this is the animated scale version. This is the bake because we are using the viewer mesh. We don't need to see that for now. I'll delete it. So that's the scaling that's happening for every Voronoi fracture, and we can control the number of fracture back here. Let me check real quick. Frame info at least split. Let's say I'm reducing this to 3 by 3 by 3, so we have only 27 fracture. So the setup is still working. Currently it's working only for this cube shape, but you can easily change the box. You scale the box and then you scale the vector P field to match the box, the boundings of the box, and then assign it to this Voronoi node, and the Voronoi node will create the fracture for you. And what's interesting here is really the scale on every fracture, which is happening right here. It's animating each one of them and kind of growing until it's reached one, and then it stops. And yeah, I think that's, for me, that's the most interesting part. And I wish I can assign it to the matrix instead of, currently I'm assigning it for every single group vertices in a way. This is the one that I want to talk about. Is the move. We already play around with the scale for each fracture, but let's say we want to move each and every fracture, so we can do the same thing basically, something like that. So if we provide like a random vector, currently we have 13 here. I'll quickly assign the list length output into the count, so we know there are 13, in this case 13 number, and we want to generate 13 different random vector. If we plug that in into this guy, we should basically, oh, actually that's probably the wrong way to do it, unless I can add a list split right here, and let's check it out. That might be correct or might not be correct. Gotta check it out. So if I zero it out in the move, we get this. If I increase the number, I kind of scatter the objects in all directions. Yeah, I think this is one way we can approach it. I don't know if this guy is actually centering the pivot of each object in a way that we can plug in the matrix here and just use a line, for example, how many, 13. It might center the object. It might actually not centering it. Um, well, probably it doesn't center it, but at least we have a little bit more control with the location there. So in fact, it's probably a nicer idea to animate it here down in the matrix. If I use like random vector lerp, and well, vector lerp might be a little bit complicated. Let's not do that. Random vector 13, plug this into the locations. So this guy is kind of, yeah, this one also kind of doing the same effects. So in a way, we do have control over the each and every center position of this object. So that's pretty good. That way we can easily like doing the rotations here. Let's doing it like this. So yeah, so we kind of managed to center pivot each and every fracture object, so you can have that kind of really cool design, and you can always go back and randomize the Voronoi thing. There we go. So different cracks for each 3D cube. Well, you can always bake it in many different ways. Actually, we have 13 at the moment. Let me tidy up something a little bit. Okay, so when I change the seed, the least length, the total number of fracture is actually changing. I think I need to summarize what I've been talking about. Okay, let's do it again, like recap everything again. So this is I start with a box. The box can be any shape. I'll just leave it like 2. That's the default. And within this box, I scatter some vector points. And this vector point should actually be within the boundary of this box. And if we make sure that's happening, we can pipe everything into this Voronoi 3D script node, and this guy will do all the hard part and fracture the cube. So that's the basic setup. And the next one I did actually with this separate loose part, bounding box, scale, and move, it's really for each and every separate fracture. I'm kind of grouping it in here, grouping it, and then center the pivot and whatnot. Basically, I want to be able to kind of animate each fracture separately. So this is, let's say this is like centering the pivot. The next thing we do, just pipe all the data in. The polygon data is really just piping in. We didn't change anything with the polygon face data. So vertices coming in and polygon face coming in, and then the next thing we provide is this matrix. This is going to be the position for each and every fracture object. So that's why we end up with something like this. Okay, the scaling is happening inside the grouping of the vertices here. I don't need to separate it. So this part is just slightly more complicated, and no, maybe there's a better word for it. It's not like complicated. This is actually the whole setup here is like complex, but using nodes like this make everything becoming very simple. That's actually what I want to say, because we can always go back, you know, change the number of the fracture, and then we can get new design very quickly. Currently, I cannot scale the box too high. It's not like the box controlling the size of the vector P field. For the next live noding, perhaps I'll try with like any kind of random 3D shapes, and then I wanna like scatter a bunch of points inside the shape within the boundary, within the bounding box, and then with that point we're gonna have like a fractured Voronoi fracture. So that this is like a more robust setup than the one I'm doing here. I'm doing it like, currently I made this setup just using a 3D cube box shapes, because that's the simplest way I can kind of think of it. Because once you understand that you can control each and every fracture object separately, like this, you can basically do anything. You can even use particles and control each fractures. Yeah, so I think this is very very powerful. I guess I need to share it with you guys, and maybe you want to try it for your Blender setup. So yeah, let me know what you think. So you can ask me anything. I try to answer it and in the comment section below. Yeah, so this is basically the whole setup. What I haven't shown you is that if we use the B-mesh, viewer B-mesh, and we pipe in all these vertices, polygon, and matrix, we're gonna get this colored result if we use the material. There you go. The material itself is a Blender Cycles materials, and yep, Blender just crashed on me, but yeah, anyway, it's okay. I can restart Blender and show you the final result, but that's the whole setup. You can control each and every fracture now and transform it the way you like it, because once they are centered, like the pivot of each fracture, you can do pretty much anything. So let's do it again. Viewer B-mesh. This is gonna output the real objects. This is just a preview. Hold shift and then drag along these nodes. That's why you can have this kind of wiring happening there, and assign a material there. And let's see, this should be on the face. And if we turn off the viewer and do a quick render, the cycles materials is looking like this, very basic. Material is diffuse, color ramp, and randomize per object. So I can change the color of this to anything. Let's say make it blue and clockwise, perhaps yellow and green, and then I can render it out. It's looking like this. And yeah, so a lot of control there. Definitely RGB sometimes give a more controllable result. Add more value there, give it a color. So yeah, a lot of control, and you can animate, and everything is really procedural, and you can do this automatically once you have the setup working for you. Currently only working on this 3D box cube, but if you just make a slight variation and change, you can make it work on text objects, on Susan head, or any shape of 3D mesh. Yeah, so that's pretty much it. Thanks again for tuning in, and I'll see you in the next video.